Okay, cool.
Cool. So, what I want to talk to you guys today about is some drone stuff. So, my background is I work in the makerspaces at Brandeis. I also teach in the business school and in the anthropology department. And we make engineering tools accessible to non-engineers. And really, when we talk about drones, thank you so much for that.
No problems.
When we talk about drones, really when people think about drones, this is what people think about. Sort of a standard fixed-wing unmanned aerial vehicle, or maybe a multi-rotor. And when we think about like uses of drones today, they're sort of like they cluster around different industries, from manufacturing to entertainment, using them for like inspection of bridges or crops, as a video production tool, or as like a sensor in the sky to get a different point of view or a different data set than you could get through a manned vehicle. But what I want to talk today is the first thing I got into drones about was iterative design. It was really like the magic of 3D printers. For me, we're looking for like the thing that's going to put one of these in every house, or the reason every consumer would want one of these. For me, the magic is it changes your relationship with your environment. Like everything is industrial design, designed by some human somewhere. And for me, the drone platform was an easy way into that conversation. And it's a slippery slope. So over the last 5 years, I've built close to 100 little robots. And all of these, we fly them from various scales. So we're going to fly some of these around the yard later and have headsets that you can see. When we fly them, though, we fly from a video transmitter on the device that goes into a headset. And sort of the difference between this platform and what Sasha was talking about is this is displaced reality. It's still real-time in reality, but you're in a container that's not your human form. It allows you to escape your human form. And what I really got obsessed with was this, is it's an out-of-body experience. It's an accessible platform that can way outperform what your human body can do. And sort of the first thing that we talked about with augmenting the human is, like, we have to learn how to give inputs to our body, either move our legs and our muscle and skeletal system, or we learn how to drive a car with wheels and a pedal. For a drone, we learn how to use 2 sticks. But whatever the inputs are, the human brain maps to it, and you can move yourself in physical reality. And these control systems are really simple. Like, this is sort of like how custom PCs were 20 years ago, mixed with how skateboarding was 30 years ago, where the pilots don't even have the vernacular to describe the maneuvers that they're doing. And it's really only like 10 off-the-shelf components. You put them all together. If it goes well, no smoke comes out. If it goes poorly, it's hard to get the smoke back in. But the good news is the parts are relatively inexpensive. And this is sort of a diagram of how the control logic works for the system. And then, the exciting part, then we fly them. Let's see if this video will work. You're supposed to autoplay. I might have to switch to the other computer.
Oh, okay.
I can do a quick switch.
Okay.
Okay, so do a lightning switch. I have the dongle here.
Is it, oh, can you try to...
the
videos like...
Yeah, they're like... They are the magic. The videos are the magic. Perfect. And then, yeah. Okay, so then we fly the drones. And so this is me flying in the Brandeis Library under my own self.
Oh, wow.
So this is flying a vehicle sort of this size. So these weigh 20 grams. These vehicles weigh maybe 20 grams. They can max out at about 40 miles per hour on the smaller scale. And we're flying this through a virtual reality headset in real time. So we turn off all of the gyroscopes and everything. You're giving direct manual machine inputs. It takes a while to learn, but then you're in a platform that you can put in places that your body can't go and can significantly outperform what your body is capable of. So I've done a lot of art gallery openings and parties with the little drones, where it's fun. You can get them near people. They're not too intimidating. And then as we go up in scale, we can... So one of the trickier things to learn to do is to isolate your vestibular input from your ocular input. Here I'm in a vehicle, and I'm flying behind the vehicle. So you can't trust what your inner ear is telling you about where your body moves. You have to learn to only trust your visual cues. The only cue we're getting here is seeing this image with our eyes. And from that, we have to make inputs about where we want to go with the vehicle. And this is what we're seeing in the camera. So it's an analog transmitter. It's not digital yet. There are some digital systems. They're not great because of latency. But what we get here is a no-delay view where there's really almost you have like 20 milliseconds between you and reality. The other thing we'll do today is we can put this on a backpack ring. So you can be in like a third-person mode, but in real time with your real body, where your neck doesn't move, but your hips will move you around. So we've trained a bunch of students to do this in different contexts. For me, it's really like a digital literacy tool that unlocks a lot of possibilities. And I wanted to show you here, like sort of as far as this goes, just the last minute here. So this is a freestyle clip. This is what one of these faster vehicles is capable of. And again, the human is giving direct inputs to this. It feels like it's your body. But when you crash, you don't have to pay medical bills. And so sort of, this is different from standard aerial photography, where sort of the magic is that we have a fixed angle, we're giving direct inputs, and we're almost doing like skateboarding, art, figure skating, by changing your point of view and moving you with us. So the point is the power of the point of view. If VVEX is cool with it, we have a couple of the bigger ones we could maybe fly along.
Yeah, man, that'd be awesome.
And then, really, the most exciting this gets, there are some really good pilots. The best pilots in the world today are all under 18. This is sort of a new hobby that came about in the last like 5 years, and mostly the people that do it look like me and have engineering jobs and are in their 30s. But more and more there's a generation of 15 to 18-year-olds that are doing things that have been impossible until very recently. So the ability, I mean, this looks like a rendering in a video game. But we have a vehicle right on the table that could do this if I was confident enough to place it right there. So sort of this last thought is the future of physical spaces. We're playing a video game in reality. We've moved our video games into the displaced reality real-time space. And now Oculus was purchased by Facebook with the idea that we're all going to put on VR headsets and we're going to commune in a movie theater where we're all actually in our rooms and we're in a virtual space. So it completely flips the nature of physical and virtual spaces. I'm really interested in outperforming my human body. Thank you, guys.
All right.